Let's do this thing. So, I must say a big thank you to everybody who has been so welcoming over here. This is my first time ever in South America, and you guys are all absolutely incredible. So welcoming and so hospitable. So, I'm here today to talk a bit about some ideas on web versus native. The idea of what stuff we have coming up on the web platform to allow web applications to compete with the native platform equivalents that we see around us. I will first of all say, don't worry too much about taking loads of notes. These slides are all up on slideshare.net/ChrisDavidMills. And then all the way through the presentation, as I have here, for example, I've included lots of links, email addresses, Twitter addresses, so that afterwards you can come and find me online and talk to me about this stuff, or you can come and talk to me in person just after this. But all of the stuff that I'm going to present here has demos available or on MDN or on similar sites, so it doesn't take a long time to find them. I don't really need to do this so much now. We've pretty much done the introduction of me, web nerd, heavy metal drummer. The only thing I suppose I didn't talk much about is I'm also a complete accessibility whinge bag. There's a lot of really interesting stuff that's now coming to the web platform, but I don't think we should lose sight of what made the web really awesome in the first place, was universal access. So remember that as you're creating your crazy experiments. Think of the people with disabilities and people on mobile devices. So what is the problem really that I'm about to start discussing? I tend to think of it as a kind of an age-old struggle between good and evil, or between code 1 or code 2 as it is in this case. But as you go around doing your web work, you will tend to hear all of these arguments. Oh, native is better because, oh, it's faster. You can get decent offline experiences working much more easily. It provides a more integrated, consistent experience for the users because you've got things like installable applications and these kind of things. And then on the developer side, you've got a better developer ecosystem, better tools and better APIs. And then, of course, we have the whole security argument. Because now, we're getting these situations where we can start to have web apps accessing the functionality contained within other apps to a certain degree. And we've got web apps accessing things like the camera and the contacts and address book of the phone, and even things like SMS and the dialer. So the skeptics out there would probably say that this is starting to sound like a bit of an NSA field day. But I'm pretty much here to prove you wrong and to start to talk about why the web platform is becoming so cool. So let's start off by looking at the app ecosystem. Now, on the Mozilla side of things, we have this Firefox OS thing. We also have similar things coming out from Google and from Tizen and other places, but on the Mozilla side of things, we now have this phone, which is actually released in 15 different countries. Pretty much it's doing everything using web technologies. It's an open source project, so absolutely everybody can get involved. And pretty much everything runs on top of our Gecko rendering engine, including the default suite of apps and the UI of the phone. That's called Gaia. And then down the very bottom of the stack, we have this underlying kernel called Gonk, which is heavily based on the Android open source project, and that's what absolutely everything sits on top of, and that's also the part which provides a hardware abstraction layer, so we can start controlling hardware from web technology. Now, a large part of what makes web-based platforms interesting is installable web apps. Installable apps are certainly not a new thing, but they're a fairly recent concept for web technologies. And the basic way this works is in the root of the web applications, we have a manifest file. At the moment, Firefox apps and Chrome apps use somewhat of a different manifest format, but the good news is that the W3C is working on a standard for app manifest format, so hopefully we'll move over to that when it's ready. Then, when you're ready to install an app on a platform, you control that using installation APIs. So I'm not going to bore you, hopefully, with too much long-winded talk about code here, but this is just a brief look at what a manifest file looks like. It's just a standard JSON file which specifies things like the name of the app, the description, the path to get to the app icons, and permissions, this is basically where the app asks for permissions to use certain APIs. So you have that in the root of your application. Then if you want to install that on your device, the code that's used is something a bit like this. You've basically just got something like, on Mozilla Firefox apps, we've got mozapps.install, and you pass that, the URL of the manifest, and it just looks at it and checks it out. And if everything's okay, it installs the app. That's it in a simple nutshell. Now, the apps can be hosted apps, which just means that they're just like a normal web app. They're set up on a server somewhere, but they've got the manifest and install functionality. Now, unfortunately, the best way, really, that would be the most convenient way to do it, but a better way to do it is with a packaged app. And this is a web app which is zipped up into a zip file and then hosted somewhere like the Firefox Marketplace. And when it's hosted on a trusted app distribution center like the Firefox Marketplace, it's verified. Verifying the app means two things. When you've got a verified packaged app, not only can you have access to kind of a higher level of APIs, basically more interesting APIs, but you can also have the app installed properly on the device. So not only does it just have a reference to the app, it actually downloads all of the assets and everything and has that set on the device. So you get part of the offline puzzle solved for free with packaged apps. So another thing to mention briefly just here is we've got APIs to allow you to charge money for web apps. We've got this MozPay API that uses payment providers like Bango to manage transactions. You can also have a verification of a receipt passed back to your app, so you can make sure that payments are actually completed and you haven't actually got people just getting your app for free without completely fulfilling the payment. And you've also got in-app payments available. But you might also be thinking, well, what's the point of having these installable apps if they're only installable on Firefox OS? As I say, hopefully there will be more standardized ways to do this stuff in the future, but we're working on web runtime, which is basically a way to allow the apps to be installed on other platforms as well, whether it's Firefox on Android or on the desktop as well. Now, in the case of Android, we have this thing called the APK factory. Now, when you upload your app to the Firefox Marketplace, if you choose to have Android as a target platform for that app, the APK factory will make a synthetic APK. It's kind of like a wrapper that sits around your web app that makes it smell and taste like a proper APK. And then that's installed using the actual Android installation mechanism, so it feels even more like a native app. And there's similar things available for desktop platforms as well, such as Mac OS X. So that's kind of the app ecosystem talked through just a little bit. I'm now going to talk about the developer experience a bit, because again, this is something where people were thinking that we're kind of falling down. We'd really like to provide a first-class experience for developers of web apps, so including decent documentation and developer tools and frameworks and other things to help make more effective applications more easily. I think the documentation story is quite simple. I mean, we've got this thing called MDN, which provides documentation on just about everything ever in terms of the web platform world. And then we've also got the Mozilla Hacks blog, which is sound bites of new interesting things that you need to go out and try because they're awesome. In terms of developer tools, I think the web platform's getting really interesting now. I mean, not just on Firefox, but on IE and on Chrome and on the other browsers as well. We're getting some brilliant developer tools available. Particularly in the case of Firefox, I'm quite pleased to see that now we have a web audio API inspector. So if you're using web audio API, you can grab a visual graph of the audio graph that you're using on your page and manipulate it. That's very useful. We have some useful tools for debugging WebGL, like the shader editor. That's really cool as well. And then a lot of you have probably heard about this thing called the App Manager, which is our kind of in-app system that allows you to grab and verify web applications and load them straight onto a Firefox OS phone or a Firefox OS simulator. Well, we've now got this kind of souped up, even more interesting version of that available called the Web IDE. Now, the Web IDE is currently only available in Nightly, but it's turned on by default. And I thought I'd just briefly show you a little bit about that. Let's have a look. I'm going to have to do this over there on that screen now, aren't I? I can't actually see that very well at all. there it is. I can't see this very well at all, given I'm looking right over there, but it's pretty much a full-featured IDE for the web contained inside the Firefox browser, so you can load up existing packaged or hosted apps that you've got available, or you can create new apps using the web IDE. When you create a new app, you're actually using what we call our mortar templates, which are various different templates to build web apps inside. And then down here, you've got the ability to look at all of the different assets that are inside your app and all of the different parts of code, and you can actually change those and save them. And when you want to actually check it out in a browser, you can load up either a simulator, or if you've got a real device connected to your machine, you can load it up in there. And so, for example, here, I'll just load up a Firefox OS simulator, and we can push our cheesy-looking demo app straight over to there. So there we go. Now, I'm not going to start trying to live demo code because I can't see it at all, but, you know, it's quite a nice thing to have available, and we're adding more features to that as time goes on. So as I mentioned this thing that we've got called Mortar, which is app templates that provide a lot of different examples of app functionality for you to write stuff straight into. We've got a thing called Brick, which is pretty much our web components effort, so reusable web components to use inside your web apps. And we've got some other interesting stuff as well, like Firefox OS boilerplate app. That's examples of all of the different Firefox OS APIs. And PhoneGap. We now have Firefox OS as a target for PhoneGap stroke called over applications as well. So that's kind of cool. Now, of course, I can't really go and start talking about web versus native without talking about some of the interesting APIs that we've got coming up. When we started doing the Firefox OS project, the mandate was pretty obvious, pretty simple. It was basically, we just want to make all of this stuff work on the web. Okay, when I say the web, I kind of mean web technologies. I just wanted to add this disclaimer in there because anybody with any intelligence is probably going to sit there and go, well, actually, a lot of these APIs aren't really standards yet. So it's using web technologies, but a lot of it isn't particularly standardized across the whole web yet, but we're working on it. Now, in terms of security, we handle this mainly by the permissions inside the manifest. So there's different permission levels. So common APIs can be accessed by any app, even the hosted apps, you know, that are just normal apps sat there on your web server. When you have a packaged app, however, you can use privileged APIs. And these are slightly more security critical things like contacts and camera and device storage. Then we've also got a top level of APIs, which are kind of the real sort of phone critical security ones. These are things like SMS and dialer and Bluetooth that you don't really want just any web page starting to mess around with. You don't really want any website that you go to start to make phone calls and send SMS, do you? So the certified APIs are only usable by the device manufacturer and Mozilla themselves. So let's just go through a few examples of some of the stuff we've got coming up. So already available in Firefox OS, we've got this thing called Web Activities. And the idea here is that you've already got lots of useful functionality on your device, such as a camera application to take pictures through the camera and videos. So you don't want to kind of have to rewrite that functionality every time you want to build another app which can grab pictures. So you can use a web activity. You can basically say, okay, I'm going to start a pick activity and my data dictates that I only want to pick PNGs and JPEGs. And when you run this code inside Firefox OS, you get something a bit like what we've got on the left here. I'm not sure how visible that is, but the idea is it just brings up a dialog box and says, you know, this application has requested a picture. Do you want to grab that picture from the gallery, or do you want to take a new picture from the camera? And then when you've grabbed that picture and it's been sent back to your app as a blob, you can just do whatever you like with it. So here we're just doing create object URL and sticking the picture as the source attribute inside an image tag. Perfectly simple stuff. Next up, I'll look at notification. So we've got an API available now in both Firefox and Blink-based browsers to allow you to fire system notifications. Now, this is pretty useful stuff because, of course, a system notification that you can basically specify will run at a certain time. If you're using the alarm API alongside that, will fire regardless of whether you're still looking at the web application, or even if you're not in the browser anymore, the system notification will still fire. Next up, we've got the vibration API, which doesn't really need that much explanation. It's just a way to tap into the vibration hardware of the device. So I want to vibrate the vibration hardware for 200 milliseconds, for example. Running through a few more, we've got ambient light events. So when your device has a light sensor, when the amount of ambient light around the device changes, it fires a device light event, and you can basically fire into that device light event. And your typical use case for this is, if I've got an e-reader application and it's dark around me, make the application brighter, and the other way around. But we've got a Mozilla contributor called Francesco, who lives in Italy, who made quite a nice Christmas card application. So as it gets darker around the device, the Christmas card changes, and then when it's really dark, it starts snowing and the Christmas lights come on. It's beautiful. I also wanted to give a brief mention to device orientation. So the idea that we can pick up changes in the orientation of the device along the gamma, alpha, and beta axes using things like the compass and the gyroscope of the device. And again, you can react to those using the device orientation events. This is basically what allowed us to use the web to create 1 million different Super Monkey Ball clones. But, you know, it's quite useful to be able to do that kind of stuff. Now, I don't think I really need to explain to anybody what getUserMedia is. I'm sure we've all played with this because it's really, really cool. But I did want to go on to talk about some of the extensions that we're starting to put into it inside Mozilla. We've recently started to add various constraints to it, for example, to allow you to not only specify that you want to use audio and video, or one or the other, but you can also now start saying, I want to constrain my video to be this width and this height. Or you can say, I want to constrain it to a maximum number of frames per second. You can also start saying, I want to add the constraint that I just want to capture my full screen, or I just want to capture the application that I'm running. So there's quite a lot of interesting things coming up there. But then another thing that I wanted to talk to you about was this new thing we've put into Gecko called the Media Recorder API. Now, if you can imagine this code going inside the success callback of the getUserMedia, basically what we do is we create a new media recorder object, and that just grabs the getUserMedia stream. And then you can use some very simple methods of that to start recording and to stop recording and to pause recording. If you press, you can easily set yourself up some buttons to control such functionality. Now, when the recording is paused or stopped, the information that's been grabbed up to that point is made available as a blob, because this is the whole point of this API, the idea that getUserMedia is great, but it deals in raw PCM data. So to actually record that, you'd have to do some complicated on-the-fly encoding or some such thing, which is not so useful. So Media Recorder just automatically converts that into whatever the current browser knows how to read. So on the onDataAvailable event, you can grab the blob that exists at that moment in the data property of the event itself, and you can just choose to create an object URL and put that into an audio tag or whatever if you want to play it. So another one that I was going to mention very briefly is we've also created our own web version of NFC recently in Mozilla. So for anybody that doesn't know, near field communication, or NFC, is this short-range radio technology that allows you to transfer files between two devices by bumping them together or just moving them close together. So that's kind of quite useful. And the idea is that you use a web activity to actually start off the process of using NFC. Then you use read NFC to actually grab the data that you want to send, and this converts it into NDEF records. You need to do a bit of conversion there because NFC understands uint8, whereas JavaScript tends to deliver strings by default. And then NFC also has this onPeerReady event. Now, the onPeerReady event fires when another device that's NFC enabled comes into range of your device that's got the NFC app on it. And then they will get a little dialogue saying, do you want to receive this NFC data? And if you say yes, you can then convert you can then get this person's device to be represented by a peer object using getNFC peer. And you'll see that in the bottom there of the slide that we can then just use simple methods like send ndef records and send file to send information over to that peer. So that's pretty simple stuff. Now, the last one I wanted to mention in this avalanche of APIs is web speech. This was something that I only really heard about a couple of days ago. I was talking to Andre Natal, and he's just released a patch. He's just put a patch into Gecko to include this in the browser. It's under review at the moment. It's a bit rough and a work in progress, but it was very exciting to actually see completely client-side based speech recognition and speech synthesis available. So that's quite exciting too. And then, of course, we've got all sorts of other things like Bluetooth, SMS, telephony, etc., etc. So, okay, so I also wanted to say a little bit about offline apps. I know that this was covered earlier on in a most excellent talk in great detail, but I thought I'd also say a little bit about this. I thought I'd call this out into its own specific category because offline apps are very important, it turns out. If you've got no connection, you've got no experience whatsoever. The three main problems, as we see it, tend to be that you need to deal with offline data storage, offline asset storage, and then detecting available network and reacting to what network you've got available. Offline data storage really isn't too bad because we've got lots of mechanisms available in browsers such as IndexedDB and local storage and Web SQL. We've also got one that's currently Firefox OS specific called the Data Store API, which allows you to have a data store that multiple applications can read and write to. Again, controlled through a series of security permissions, only available at the moment in certified apps, but hopefully the security level will be brought down soon because it's really quite a useful thing to have available. So there's something available for offline data storage in most browsers. Another thing that's useful to look at is one of our developers, Tofu Matt, created the local forage library, which is basically just a polyfill for offline data storage. It provides a simple name-value pair mechanism for storing data, and then in the background, it will use IndexedDB if it's available, but if IndexedDB isn't available, it will use Web SQL, for example, if it's a browser like Safari, which doesn't support IndexedDB, and then it will even fall back to local storage in really old browsers like the earlier versions of Internet Explorer. So local forage is certainly worth checking out. Now the next problem, the offline asset storage. This is much more of a pain. As I said earlier, packaged Firefox OS apps or packaged Firefox apps are installed and available offline by default in terms of the assets. But this doesn't really help the web at large, does it? Because that's just Firefox apps. Now, we did have this thing called app cache. We did mention this earlier, this lovely thing called app cache. Now, this did have promise, as was said earlier, because it gave you this lovely simple syntax to put in your app cache manifest file. And it was really easy to say, I want to cache these particular assets of my web app, but I don't want to cache these ones. And it was all nice and lovely, and it did lots of magic in the background. The trouble is, it turned out to be actually fairly evil because it did a load of strange stuff in the background that was really quite rigid and inflexible. And if your app didn't work exactly the way that the app cache spec worked, then everything kind of burst into flames and it didn't work very well at all. So detecting network state is also a bit of a pain. We do have this thing called the Network Information API, but it's not particularly very reliable. The problem really is you don't really want to detect network yes, no. You also want to detect things like how much network you've got available. And in these cases where you're, for example, on a train and your network connection is fluctuating all the time and you may have lots of network one minute but none the next, it's not very useful at all in that circumstance. You could do things like checking XHR responses, but it's not ideal. It feels a bit hacky and it doesn't work well all the time. So in response to that, I will say, hello service workers. As a death metal fan, I think this is what every musical crowd should look like. So as mentioned earlier, service workers are coming. We've currently got parts of the service worker spec implemented in both Firefox and Chrome, which is great. So, as was said earlier, I'll just summarize this because we already had this today, but service workers are basically bits of JavaScript that act as proxy servers that sit between your app and the browser and the network. They can intercept network requests and customize the responses in any way that you want, and they win where app cache lost because the syntax is a lot more complicated, but it allows you to control everything in a much more granular way. So just briefly to go through how this works very basically. So I've got a bit of feature detection there to say if service worker exists in this browser, register the service worker using service worker.register. So you point to the URL of the actual service worker file. You can also optionally declare a scope bit of data if you don't want every single asset in your application to be under the control of a service worker. You might just want some of them to be controlled under a service worker. So once the service worker's registered, we then have the install process like we talked about earlier. So once the service worker is installed, getting installed, the install event is thrown. And this is pretty much the point where you say, okay, here I'm going to use the cache API to add all of these different files that I want to have available offline to the cache. So the cache API that goes along with service worker is this kind of nice programmable HTTP cache that we've got available, and it's very, very useful indeed. And then when a file is requested by a part of the app which is under the control of the service worker, this fetch event is thrown, and then using the fetch event you can pretty much control the network requests and responses, well, the network responses in any way you want. So just to briefly run through this code, we've got this event.respondWith, which basically means we want to respond to the network request with something inside that block. We've got caches.match event request. So basically what that's saying is we want to respond to the request with the response that matches it available inside the cache stored offline. So that's the first part of the puzzle, but then you'll see we have this catch block attached to the end of that. This is the third line down that we're looking at. Now inside the catch block, we're basically saying, okay, so it's a catch block, so we're saying if there wasn't anything available in the cache which matched my request, then let's return event default. And that means instead just go to the network as you normally would and get the file off the network. But we're going a bit further there as well. We've got this return caches get v1. And that basically means grab our cache that we've got that we called v1, and then cache add event request. Once we've grabbed this thing off the network, add it into the cache so that the next time it's requested, it will be available offline if it wasn't this time. But then at the bottom, we've got a further cache, and this is the beauty of this kind of promise type architecture that we've got in service workers. We can chain all sorts of catch and then blocks together to get these long strings of instructions. But anyway, at the bottom, we're basically saying, okay, if neither of the previous two options worked, then just return this fallback file. Now, it may not make sense to return an image as the fallback file for every request, but in this particular case, it's just a simple little image gallery app. So the idea of service workers is you don't particularly have a foolproof way of calculating if the network is available, but you're able to specify what should happen if it's available and if it isn't available. So that's pretty much service workers in a nutshell. We've got a high hope that that will allow us to create decent offline experiences. So the very last part of my talk that I wanted to go through just a little bit is some performance enhancer ideas. Because again, people have often complained about the web being slow. So let's just go through these briefly. Now, web workers, I'm sure you've all heard of web workers. The idea is that you can run scripts in a background thread. So the idea is that you can do kind of number crunching stuff in a background thread so as not to block the main execution thread. So getting rid of some of that jank that you often get in UIs. So that's one thing that we've got available, which is pretty useful. Next, I wanted to briefly mention some of the other stuff we've got available. So this set of stuff isn't really stuff which directly increases performance, but it does improve the user experience and make things appear more seamless. It's kind of good for a more seamless experience on the device. So pointer lock, the idea of pointer lock is that we can just hide the mouse pointer, and instead of your mouse movements moving the pointer around, they can just be grabbed and used as data. So you can use your mouse movements to just move a 3D environment around that's created in WebGL, for example. That would be a typical use of it. We've also got a full screen API available now, so we can actually make proper use of the full screen with web apps. And then screen orientation API for locking the screen orientation, because that's another thing. There's nothing more annoying than having a really cool UI for a game that works in portrait mode, but then it kind of gets ruined in landscape mode. Yes, we have got a lot of responsive design stuff available now, but quite often you just want the UI to stick the same way. I also wanted to give an honorable mention to the Web Audio API. Web Audio API allows us to play back and manipulate sound and control it in a very precise way. You know, you can say exactly when you want a sound to start playing. You can add effects to your audio. You can also split and merge audio streams. You know, you might have 5.1 or quad sound available, and if you want to, you can split all of these audio streams into separate streams and manipulate and add effects to each one of those separately. That's very, very useful. You can also spatialize audio, which means that you basically have a panner object and a listener object, and both of those can be given a position inside a 3D Cartesian coordinate space. So you can basically say, okay, well, I'm fixing the position of my panner object here, and that's basically the source of the audio. And then you can move your listener around, and it will simulate the effect that it would have if you were in a real room moving around a stereo, for example. So that's really, really useful. And then audio visualizations are also a pretty cool and interesting thing that we can do. We can quite easily grab frequency data or time data from your sound and then create things like oscillators. I'll actually show you a demo, and I'll actually show you a couple of demos now. So where are we? So the first one I wanted to show you was my little web dictaphone. Now this is actually a media recorder API example, so I don't actually have sound available here, which is a bit of a shame. Actually, you might be able to hear this through the microphone, so if we record something, so hello, BrazilJS. And then we'll just give our sound clip a name. And then that's directly outputted that.
Hello, BrazilJS.
So there we go, so that's just directly recording. And then in terms of the Web Audio API, I've got this rather interesting oscilloscope here, which is just basically grabbing the audio signals from my voice and just putting it into a waveform. So that stuff is pretty easy to do. The other really cool thing about the Web Audio API is it allows you to make demos like this. It was actually my wife that made me put a mute button on that demo after having to listen to that for about 3 or 4 hours. But yeah, so that's pretty much what we've been doing inside Mozilla with the Web Audio API, is just creating ridiculous online theremins. So another thing I'd like to mention, which fits in quite nicely with Nick's earlier in-depth talk about WebGL and all of this interesting 3D stuff that we're doing. At Mozilla, we invented this thing called asm.js, which is a very efficient low-level subset of JavaScript. So the idea is it is just JavaScript, so any browser can run it because it is just JavaScript, but it's a low-level subset which is suitable for ahead-of-time optimization compilation. So if you do run that in a browser which supports AOT compilation, you can have much faster code. And Another exciting announcement that we had a while ago is Unity 3D now has support for asm.js and outputting as that kind of code. So that's really, really cool. Going along with that, we have this thing called Emscripten. And this was invented by an insanely clever guy in Mountain View called Alon Zakai. And the idea here is that it's an LLVM bytecode to JavaScript compiler. So you can get LLVM bytecode, such as what might be output by C++, and you can compile that into JavaScript and run it on the web. And then it does quite a lot of translation of different libraries and things. There is some stuff that doesn't translate so well over to JavaScript, so some stuff needs to be done on the JavaScript side, but basically it's a way of porting native C++ games over to the web. I mean, there was a bit of bitching on, I think it was Hacker News a while ago, where somebody basically said something like, well done, you've created something with the complexity of C++ and the performance of JavaScript, well done. But that's not the point. The point is that it's a useful target. You can actually have the web as a target for your native platform code, in addition to the native targets that you might have for it. So allows us to run things like this inside the browser. So that's already getting kind of cool. I'll not dwell on that one for too long. We've also been doing a bunch of work in trying to get this to run effectively on mobile and tablet. But of course, the drivers and things are kind of all over the place on such platforms. So that's a bit more work. But yeah, that's already looking quite cool and hopeful. Now, I'm pretty much coming to the end of my talk now. So here I've just basically got a slide full of resources that you can go and check out if you want to find more information about some of this stuff. So yeah, I think I'll leave it at that for now. This is pretty much the end. Thank you for listening.